Welcome friends, this is Zubair Altaf Qureshi. Welcome to my channel, and this is part 5th of my VPN session. And before I start this session, uh, I want to like request you guys who have not subscribed to my channel, kindly subscribe, like and share my channel. And I see a lot of support from your side, and I need more and more support. And so let's begin. Let's see what all topics are we going to cover in this session. And so the topics that we are going to cover here is DMVPN, right? Then multi-point VPN, and we will have different phases of the VPN: phase 1, phase 2, phase 3, and then differences between phases, right? What is the difference between phase 1, phase 2, and phase 3, right? And obviously I'm going to demonstrate all this on my virtual lab that I'm building on EVNG. Okay, so without wasting time, let's begin. So I have this lab. This is the lab that I have, and what I can do is I have to configure the basic topology, right? So as you know, that this I mean the interlink, the network between R1 and R6 will be 16.0, and R1 would be dot 1, R6 would be dot 6, right? So let's configure quickly. Okay, let me grab up a notepad so that all this is very quick, right? So I'll just try to do this very quick. So what we will do for R1, okay, R1, enable config key interface Ethernet 0/0, IP address is 150.1.16.1, right? 255.255, 55.255.255.0. Then I'll do no shut, and then I have some loopbacks, interface loopback 0, IP address, and that is 10.1.1.1, 55.255.255.0. Okay, 0. Then I am interface loopback 1, IP address 10.11.11.11.255.255.255.0. So this is the one, and then I should have a default route towards my I'll do exit, then IP route towards my internet, right? And the next hop will be here 150.1.16.6. so 6 is my router 6 is my what the I did exit, right? So that means I came out of this, and then I'll do right. So R6 is my internet, right? So I'll copy this on my R1, copy, go here, say no here, say no on all the routers. So here I have kept R2 on hold. I'll use this later on in my video. Okay, I'll let you know why we will be using. So I'm missing R6, right? I mean R5, so I need to disconnect. Yes, R6 is what? R6, let me see, it's 7.4, so that means R5 is 7.3. Here it should be 3. Okay, R5, say no. Nice, let's go to R1, copy this again and paste. Nice, right? And also the host name, I forgot it, R1, right? Do write mem, so I can keep it here, host name R1. So this was for R1. Let's copy paste this for R2 and all other routers, right? So copy and enter and paste. So this will be our R2. R2 would be 26.2, right? 26.2, and all the IPs would be 2.2.2, 2.2.2, and then it should be 22, 22.22.22, and this should be 26. That's it. Yeah, and name should be. So I'll copy this and go to R2, and here not able to. Okay, I don't have R2. R2 is my I'll be using it later on. So this should be 3.3.3.3. I think I should keep this, right, R2, but I'm not using it right now, so I I will be using it later, right? So I'll just do this R2, and now what we'll do is I'll copy this again for R3. Copy and R3. So R3 goes here, R3 goes here, 36 dot 3, right? And this is 3, 3, 3, 33, and 33 and 33, right? And this is like 36.6, and copy, Control C, go to R3, nice, right click, done. Nice, no? So using Notepad has its own plus points, right? Let's go to R4 now. R4 and 46.4. This is like 4. Oh, Control C, 4, 4. This is 44. This is 44. This is 44, and this is 46.6, right? Copy, nice. Go to R4, paste, done. And now R5, right? Copy, R5, R5. So here I'll change 5, 56.5. I have 5, 5, 5. Here it goes 10.55.55.55. Next stop is 56.6. So again copy for R5, go to R5, enter, done. Now R6, right? R6 is internet, so I don't need much on the internet. Okay, let me just keep it like this. On R6 I just need IP addresses on the interfaces, that's it. No route, nothing. So I'll go here and go into the config mode. So I'll say interface ethernet 0/1 is going towards R1, right? So this is IP address is 150.1.16.6, right? 255 255.255.0, no shut, and then I'll go to which one? 02. Let's go to 02, and this is like 26, right? 26. I'll not unshut this, I'll keep it shut, and I'll go to 3. 3 is my 36. So 36, and I'll do a no shut on my 3. Okay, this one, and then I'll go to my 2, done. 0 0. This is going towards what? 56, right? 56, no shut, and then I have 1 0. That's 0. IP address should be my 46. 46, and a no shut, and I need a no shut. Done. Exit and right. Host name is R6, R6 internet. So this is my cloud. Okay, done. Exit. Right. So I don't need R6 now. Let's go to R1 and see if I can ping my public IP address. Okay, ping 150.1. Say 56.5. That is my R5. Right, that should be reachable, right? All the public IP should be reachable. So R3, and then 26.2 reachable. Okay, 1.26.2. Who's okay? R2 is not reachable because it's shut right now. And 46, right? 46.4 should be. So yeah, so this is the like the basic requirement, right? All the public IP should be reachable. So let's begin and let's do the configuration. So configuration for the DMVPN is will be building up on the GRE configuration, right? Like GRE, like mGRE, we have interface tunnel 0. So I'll go to R1 interface. Okay, enable. If I am not in the enable mode, config T, then interface tunnel. Let's keep tunnel 10, and then we have the IP address. IP address I'll keep 128.168.1.1 for R1, like that, 2 for R2. Okay, that this is the tunnel IP address. Okay, then you have the tunnel source. Now you know why we use tunnel source, right? So this should be the public IP, right? So this is 16.1, and tunnel destination. So tunnel destination. So if I specify tunnel destination, that means it's point to point, right? So I'll not specify tunnel destination. Instead, what we will do is we will say mGRE. So here you specify tunnel mode GRE multi point. Okay, that means the destination is not static, right? So you need to go to your NHRP table, right? So for that you have to specify the IP NHRP network ID. Say I'll keep this as 123 or 111 network ID. It can be anything. Then you can also have authentication between the NHRP like host. So I can have IP NHRP authentication Cisco 123. So this is the configuration on R1. So let's go and paste it on R1, copy, and this is the one. I'll go here and paste it, right? Yeah, so this is done. If you check now, show IP interface brief here. Do show IP interface brief, you will see tunnel interface 1.1 and it will be reachable. Do ping, check this, it will be up, right? So let's go to R3 first, R3, yeah, R3, and I think I have this copy. Let's copy again. Go to R3 here. Right? What changes here is the 3 and 36.1 is my source. Rest remains same. Copy, and let's go to R3 here. Nice. Exit. Okay, and if I do a ping, do ping 192.168.1.1, that is my R1 tunnel interface, right? Will it be successful? If you remember from my I mean the GRE section or the mGRE section, what happens here is you have the outer header and the inner header, right? So likewise it will be successful, right? So if I explain to you on my this pen, let me grab my pen. Okay, so just to explain you guys, yeah, here I have my board. Let me grab a pen. Okay, so what's happening is I have my R1, right? This is my R1. Okay, and it's connected to the internet, and from internet I have R3 also. Okay, and the IP address, the tunnel IP address is .3 here and .1 here from the 192 range, 192.168.1.0, right? So this is the tunnel. What I'm doing from here is I'm doing a ping. So my source, okay, is what? I'm not specifying the source interface, right? I'm saying I just want to ping 192.168.1.1 from R3, right? From R3. So my destination, so say destination and say source. Actually, source should be first. Anyways, so destination is 192.168.1.1. So what happens is it checks the routing table on R3, right? R3. And what does it find is, let's see what's on R3 routing table. Go here, R3. If I go and say do show IP route, right? And I see for 192.168, I'm on R3. Yeah, I'm on R3. And what about the tunnel interface? Let me see. Do show IP interface brief. I have this interface. Right? Why and this showing in my routing table? Okay, if I go to my R1 to show IP route, See, I have this in my routing table, but what about R3? What happened to R3? Should be there because interface is there, but it's down. Oh, okay, it's down. Why it's down? It's down, it's down. Let me see. Do show interface tunnel 10. Let's do some configuration here. 124, 13, loop back. Okay, loop back not set. Loop back not set. If you go here, do show interface tunnel 10. It's the same, so this is not the issue. Okay, my source is what? 36.1. Okay, source is wrong actually. So this should be 36.3, right? So that is the problem. Interface tunnel, my tunnel is 10, right? So tunnel source, so I'll copy this dot 3, right? Exit. Now if I see do show IP route, I should see now my route, right? So when it checks the routing table, it sees 1.0 is connected via tunnel 10, right? So tunnel 10, when it sees the exit interface is tunnel 10, what it does is do show a run interface tunnel 10. It goes into inside the tunnel 10 and it checks what's my source and what's my destination. Source is this one, and tunnel mode, the destination is not specified. So what will happen is this packet, right, it will be incomplete in the sense, so source, it ultimately takes your public IP, right, first. Then when it sees it is going through the tunnel 10, it takes this IP as the source here. So here it will be what, say, yeah, 192.168.1.3, because it's leaving through which interface, tunnel 10, right? So that is the IP address as the source. But destination, it checks the tunnel source for the public is this one, right? So this is 36.3. But what about the destination? There is no destination, right? So we need to create the, remember, this table. We need to create this table. So if you go here now and check this ping, it will not be successful. Okay, let me go to R3. Do ping 192.168.1.1 and it will fail. And if you check the packets, it will, the encapsulation will be failed. So what you need to do is we will create the NHS, remember. So on R3, what you need to specify extra is the NHS, remember, here on R3. So we are on R3, right? So extra command that you get here is IP NHRP, right? IP NHRP and then NHS. Yeah, this one, that is R3. Yeah. IP NHRP, NHS is your 192.168.1. So that is your public IP. Then you have to map this with, sorry, the private IP. Then you have to map the public IP, right? IP NHRP map 192.168.1.1 with the public 150.1 dot which one? This is 16.1, right? That is my 16.1. So this is it. So once you do this, you will see a registration request going on. So let's do one thing. Let's run the packet tracer here, or okay, here. Export, sorry, capture on this, and you'll see that registration request received. Okay, let this start. Okay, my shark is starting, and once this is started, what I'll do is I'll paste those commands, right? These commands. Okay, started now. I'll paste these commands again. I don't need all of them, but yeah. So this is 36.3. That was the mistake earlier. We did a t-shoot, right? So on R3 we'll go and paste this command. exit. Now let's see, we have a registration, remember? So 3 went to R1 and registered himself, right? 3 went to R1, registered himself. Let's see, this is a request, and the header, you can see source address, all these packets, right? Authentication we said, so that's why authentication is there. Now if you go, now let's keep this capture running. Now if you go to R1 and check the mapping, right? Show enable show IP NHRP map. Map show IP NHRP. What is the command? Brief here. Brief, if you see, you have what? You have a mapping of 1.3, right? Via 1.3, and the NVMe is what? The public IP is 30.3, and the mode is dynamic, right? So that is what I want to show you. This is dynamic. So see, show if so if you see show IP NHRP only. This is what I want to show you again. So I have a mapping of this with this, and check the time. So the dynamic mapping has an expiry of 2 hours, and after that this mapping will go away and a new mapping will be created when the traffic is generated, right? So this is what you need to remember. This mapping has a expiry time of 2 hours, while a static has no expiry limit, right? So this is done. Now if you check that I mean that packet, right? Now what will happen is, sorry, let me go to my board. Now what will happen is, once it checks the destination, right, it will go to the mapping table, right? It will go to the mapping table. Again, I need to grab my pen actually, yeah. So it will go to the mapping table, and now I know who this 192.168.1.3 is, right? So here in the destination it will put up 150.1.16.1, right? And that thing that was not successful earlier will be now successful. So if you go here and do the ping from R3, remember the ping, let's see if it's there. Yeah, this one. So this will be successful. If you go into your Wireshark again, you should receive this from R3. You're receiving one. You have the ICMP. Remember the like header, right? You have the data payload, that is ICMP in this case. Then the inner header, then the GRE encapsulation, then the outer header with the public IP address, right? So that is it. So let's minimize this. Okay. Likewise, let's do this for all of the other spokes, right? So I have to go to my this one. So R3 done, right? Now let's go to R4. So I'll copy this on R3 and I'll go to R4 here, paste it, right? So here on R4 I need to change this one, and this is 46.4 my source. This remains same for all of them. Let's copy, go to R4, enable, and then done, exit. Now if you go again to R1 and you see this, I should have 2 now. Oh, not now, because I didn't generate the ping. So let's do a, no, it should be there because this is dynamic. I think some issue is there. Again, I'll check show IP interface brief. Do show IP interface brief. So I can see 1.4 is there. So if I go to my Wireshark, right, I should have some of the request again. Yeah, I have a request from R4, right? So why am I not able to see show IP NHRP? Okay, it is there. So it was not earlier. So it is there. Now that's done. Let's go to R5. There are three spokes only. So R5, right? This one. And this is what R5 is your 56.5. Right? And this should be 1.5 space. And this is same. So copy. Go to R5. Easy peasy, right? Exit. Now if I go to R1 again, I should see another request, right? I should see another request from. So this is 4. Yeah. So I have request from 5, and now if I see, I should have 3 mappings. So this R3, R4, R5, right? All dynamic. Unique registered, use next hop. Okay. Let's try pinging from R3. I already done. Let's try pinging from. Do ping 192.168.1.1, right? This is successful. So nice. Now we have the the tunnel setup, right? But the main job is actually to for the the loop packs to talk to each other, right? So that is what we need. So for that, what we'll do is we'll run a protocol, right? Say EIGRP on all the uh, spokes and the hub, right? So if I go here config t router EIGRP, right? So before doing this, just remember we have mapping for the, just remember here, okay, on R1. Say let's analyze one of the spokes, then you will understand for all others. So say R3, right? You have a mapping for 1.1 and you are sending it to 1.1, but 1.1 you are sending it to 150, 116, 1, right? But what about the ERGRP package? Understand? You have that the multicast address, right? You have the hellos going to the multicast address. So in the destination you have the multicast address. So for multicast address you should have some, again, what, that translation, right? The external header. So what we will do is, whenever the spokes have anything related to multicast, you need to send it to the hub, right? Because this is a hub and spoke topology, so everything goes via a hub, right? So for that, what you do is, on the spokes you say IP NHRP map multicast, then the IP of your hub. So that means whatever multicast you have, you send it to the hub. That's simple as that. So once hub has that multicast, right, hub also needs to send it to the other spokes, right? So this is not okay, this is on the hub, but the spoke, right, spoke needs to send it to its peers, right? The hub needs to send to its spoke, right? So for that also you need to like put a command, that is IP NHRP map multicast, whatever multicast you get, and you have to send it forward, right? You send it to, see, I cannot put an IP address there, right? But what I can say, a keyword dynamic, that means whatever dynamic mappings you have, send a multicast to those spokes, right? That works, right? That's how it is. You have this 3, 4 and 5, so all the multicast will be sent to this 3, 4 and 5, and anybody who's down will not be sent to those. So that is how it will work, right? So let's go to my I need to go to R1 for this, right? R1, yeah, and the interface tunnel 10 interface. So I'll go to interface tunnel 10 and I'll see this command. Great. Without these two commands, your routing protocol will not work. So now on the this one, right? So I have to say this thing on R3 interface tunnel 10 paste done, R4 interface tunnel 10 paste done, interface R5 interface, sorry, the router R5 interface tunnel 10 paste done. That is it So now you have the mappings actually placed for your multicast traffic also. Okay, so now that is done, let's run the uh, routing protocol. So we'll be using what do you say, your EIGRP in this case. Okay, so let's go to your router 1 and say uh, router EIGRP. I hope you know how to like run router EIGRP, right? No auto summary, very important. And then you specify the network. On R1 I have 10.1.1.10 slash, I mean 255 as done, and then I have the 10.11 0, and then I need to specify the this one dot. So on R1 1.1 I'll make it exact, match it exact. So this is done, right? And I can go to R. So if you see on R1, it should start sending those ERG packets. On R1, right? I'm on R1, correct? Okay, let's go to R3 and start sending those. I think it should be on the upside. Those are the old ones. So it should be somewhere. I think it's no, these are not the ones. Anyways, let's go to R3 and say I configure the router EIGRP 100, no auto summary, network 10.03.0.255, and if a network 10.33.0.0.25. I have three zeros, yeah, that will work. 192.168.1.3 and exit. Now if I see show IP, sorry, do show IP EIGRP neighbors. No, I don't have any neighbors. Okay, do show IP EIGRP interfaces. I have my tunnel interface. Okay, router EIGRP 100, and I say what network 10 192.168.1.0. It needs the guard mask. That's I'm correct there. So I have specified, right, this thing. So if I do show IP protocols, so I have my what, yeah, GRP 100 is there, right, and I'm running routing for 333 and 192.161.3, right? That is my do show IP interface brief. You may see that is my tunnel IP, right? So this is fine. Then I'll stop this capture and I'll capture this on R3 E00. Wait for the Wireshark to come up. Okay, hellos are going. Nice. So I'm sending the hellos, and where are the R3? I should have neighborship, right? So IP EIGRP neighbors. I don't have that neighbor. Anyways, let's check what's happening there. Oh, okay. My mistake. Let me check my what the. I think I have done the mistake in my configure interface. Show run interface tunnel 10. So what is my multicast? Oh, so that is wrong. Here I should have my public IP. So that's why the problem. Because you saw it's doing 3 times that encapsulation. Right? It's not able to figure out the public IP address if I give this. So okay, what I do is I go to this interface tunnel, and first of all I'll say no to this, right? Nice, and then I say like public IP of the R1. This is this one. Okay, so I'll copy this, go to my R4 and do show run interface tunnel 10. Nice. Interface tunnel 10. I say this 150, and if I say again this thing, so yeah, so no to this one. Nice, and go to R5, do show run interface tunnel 10, interface tunnel 10, and then this is no, I mean, like, first I have to specify no keyword, and then this, and then the public IP of R116.1, right? So I think that is done. From R1 I need not do anything. So okay, so if I go to R3 now and config key, so where's the Wireshark? Yeah, I have the update packet also. So you go here, you can see now it's only 2 encapsulations. So this is perfect. Now I should see the to show IP GRP neighbors. It's still not there. Wait a second. What about R1? Let's check on R1. It's up. Okay, it's coming up. Do show IP GRP neighbors. So I have it 3. What about 4? So let's close this, and I need to see on this. Where's the problem? It should come up. It takes some time, but let's see if we have any problem in my configuration. Right? So for the configuration, if I go here, multicast, right? For this is for, so R1 is the, so multiple dynamics is fine for R1, and for R3 it should be yeah. So this one should be here on R1. Oh, sorry, on R3, and on our map I've not done multicast, right? On R4 did I do? I need to check. Map multicast this on which R4 interface tunnel, and go here. Multicast goes to your 16.1. That is fine. What about this? So let's check. I'm receiving from 1.1. I'm not receiving from any other. So let's go to R4 and R5. Some problem with R4. Right? Do show run interface tunnel 10 if I do. Right, I have the IP address here on 1.4. My authentication is fine. Mapping I'm doing from from my 1.1, that is 150, 160. Multicast fine. NHS is this one. Source is this one. So let's go to R4. Where's the R4? This one, right? I'll copy this again and paste it once more on R4. Where's R4? Yeah, that's the one. Exit and paste. Exit, right? Should receive from R4 command R3. It's only R3 for now. You can see the multicast, right? So let's grab one of this. So you have the GRP, right? You can see destination this, and destination is changed to 116.1. So that is how it should be. And if I do a thing to 192.168, that is successful. Yeah. What about the EIGRP packets? I'm not able to understand why. Okay. Router. Let's see. Show run section router. I think EIGRP is fine. Show run this. I mean, Didn't I configure EIGRP here? Do show run. Oh my god. Oh, I didn't configure EIGRP. And what about this? Do show run section EIGRP? No. Oh, we have no EIGRP, and I'm thinking of where the EIGRP packets are. Okay, so then router EIGRP 100 no auto network is on R4 10.4.4.0 0.0.255 network 10.44.44.0.0.255. Then I have the network 192.168 168 1.0 0.0.255 done. See, neighborship is up. Okay, thank god. Now this, I was thinking like, what is the problem? Network EIGR router EGRP 100 no auto summary. Network is your 192. Oh, yeah, 192.168 1.0 0.0.255. This is my R5, right? Network 10.5.5.0 0.0.255. Then you have network which one? 10.55.55.0 0.0.255. Done. I should have. If I go on R1, I'll check the neighbors. Yeah, I have the neighbors. Okay, if I check like this, I have R1, R4, and sorry, R5, R3, R4, R3, R4, R5, right? But if I go here, so how many neighbors should I see? Show IP, EIGRP neighbors, right? Most of you guys will be thinking three neighbors. No, it's only one neighbor. It should be only one neighbor, and that is not still there. Let's get show IP, EIGRP neighbor. I have here, but what about R3? Let's go here again. Show IP EIGRP neighbor. Still to come up. So here it's there. I mean, like something is happening on R3. Thumbs up new. Okay. Retry limit exceed. So some problem is there with your R5 and R3. We need to figure this out. Okay, let's go to R3 first of all and see show run section EIGRP. Show run section EIGRP. Where's the section S? Yeah. So on R3 I have show IP interface. What if I do? I have loopback on 3 that is running EIGRP, this is running EIGRP, that, and the third one is also running EIGRP. That is fine. Then I go to my show interface tunnel 10. Show run. What happens in interface tunnel 10 is IP address 1.3 is there, fine. Then authentication is fine. Then I'm doing the mapping from 190 to 168 1.1 is to 16.1, fine. Then I multicast, I'm sending to 16.1, fine. NHS is my 1.1, fine. Tunnel source is 36 mGRE. So that is like all okay here. Right, I have the network ID is 111, that's matching, and IP address NHS I'm specifying, and what, and the mapping I have for the NHS also, yeah. Then multicast I'm sending, right? Can you guys think what is the problem here? No? Okay, let me give you some time. Okay guys, still not figured out, huh? If you see here, I have only one neighbor. I should have actually one neighbor. But what about this one? No neighbors. So let me give you a tip. Okay, whenever you do this, I mean this EIGRP. So on all the tunnel interface, we give the shutdown command. Try that. Let's try this here. If it works fine, then we will fix like configuration wise all is fine, and this can be the issue. Right? Do shut everywhere tunnel interface and do no shut one by one. Interface tunnel 10 shut, and let's start with R1 no shut, and then let's go to R3 no shut, then let's go to R4 no shut, and then R5 no shut. Let's check here now. So I have neighborship with 3, 4. Nice. I should have with 5 also. Yeah. So this was already fine. Show IP GRP neighbors. But the neighborship from R4 and R5 was not there, right? So and show IP GRP. Yeah, now it's come up. Show IP GRP neighbors. Yeah, it's there. Show IP GRP neighbors. So now you can see from R3, R4, R5 I have neighborship with the hub, but from the hub I have neighborship with all three. So in this case, if you want to have neighborship with all spokes, I mean all spokes should be neighbors with each other. You need to disable the the split horizon on this interface, not the physical interface, the tunnel interface. Yeah. Then all your spokes will be neighbors with each other. So let's do that. Let's go to R1, right? Config T interface tunnel 10. So 10 is the interface tunnel, and I say no IP, IP split horizon. Split horizon, yeah, PIGRP 100. So once you do this, now when you go to your R3, R4, right, should have neighbors with okay, it should take some time, and I should see neighbors with all the routers. Should do the end, and I should see show IP numbers. I'm not able to see. It should come up in a while. If I go to R3, if I check this. Okay. So so this is actually phase 1 actually. So you will not see neighbors. So neighbors, the spokes will always be neighbors with your hub. Okay, spokes will never form neighborship here, spoke to spoke. Okay, so that is how it is. The control plane remains like that, but the data plane will change in phase to phase. My mistake, I was thinking of some other VPN. So that is how DMVPN behaves. Okay, so now what you will see is after giving this split horizon, right, what you go is you check the route, and you will see all the routes, that is of R5. This is me. I have R3, I have R1, I have R4, right? So if I ping from here, ping 10.3.3.3 source of 10.5.5.5, this will be successful. And if you go so that is how it is, right? That is how it is. But if you do a trace route for the same thing, 10.3.3.3, and source of say look back to 0, let's try the source trace route. It will go via your R1, that is your hub, right? So let's wait for this trace route to complete. Yeah, goes to R1, right? Goes to R1, then it will go to your R3. Yeah, 1.3. So that is how it reaches. If I do it again, it will follow the same sequence. right? So this is actually the phase one, wherein data plane as well as your control plane is via the hub, right? So that is phase one. Just again, I will just explain to you how many times you do this trace route. This is going to go via the hub, right? So this is your phase one. All the traffic, whether it's data plane or your control plane, it is going to go via the hub. Even if I go here and do a trace route to 10 dot say 5.5.5, right, and source of my loopback is 0, so it is going to go via again 1.1 and then to my 5, right? The I think that 192.168.1.5 will be shown in the uh, next hop. Okay, uh, that is 1.1 going to R1, right? And then next stop will be your R5, 1.5. This come, yeah, so 1.5. Yeah. So how many times you do it, it will be the same. So that means this is phase one. Okay, let's move on to phase two. For phase two, it's quite simple. What happens is, if you check here, show IP route, right? You see the next hop, right? What is the next hop? Always 1.1. So what happens whenever R1 has to send traffic to any of the loopbacks, it sends to 1.1, right? In phase two, what we do is the next hop should be this R3 for 33 and 33, and should be R5 for 55 and 55, right? Likewise, for on R5 for 4, it should be, I mean 46.4 for 4, not 46, 192, 168, 1.4 for 444 and 44, 4, 44, 44, 44, 44, right? Oh, so much to say, right? And what you do is you go to your, I mean R1, okay, config T, you go to the interface tunnel 10, okay, tunnel 10 here, and you say no IP next hop self EIGRP 100 end, right? Okay, we change the next hop self, right? Let's go now to the same this thing and check the IP route. Remember this thing? Let me just expand. So now here you see 1.1. Now what do you see? 1.3 for R3, and for R5 you see 5. Now let's do from R4. I think I have the trace route, and this one. So I'm going to 555, right? So what will happen is, I mean, in all the phases, the data plane is always going to go via the hub. Okay, sorry, not the data plane, the control plane. What we control is the data plane. So control plane is always via the hub. So phase one, phase two, data plane gets changed. So first packet is always going to go to your R1, okay, and then your R5. So next time when I do this, it should go directly to my where R5. And if I check my own NHRP table, I should see a dynamic like NHRP map for my 1.5. I'll show you that. Let's wait. See, directly to 1.5, right? This is DMVPN phase 2. So if I do this, I see a mapping for 5. So go here, show IP NHRP. If I do, right, I have for 1, for 5, right? For 1 and for 5, I have this. What about 1, 4, and 5? This is on R5, right? R5 is much like 4. What about 3? 3 I don't have. So if I do here a trace route for, let's see, 4 I have, right, on 5. So if I do trace route 10.4.4.4, source of loopback 0. If I think it should, because I have a mapping, it should go directly to I mean from this it goes directly to 4. So it should have only 1 if I've done the same loop back, right? If I did from loop back 1, it will go to R1 first, then no. This was resolved, that's why it went directly to Now I have 4, I don't have 3, right? From R5 I don't have 3. So let's do a trace route to this thing. So you'll see first packet will go to my hub, and then the like consecutive packets will go directly to my directly to the spoke. So I'll have a mapping for that spoke. Right now I don't have a mapping for say R3, right? I don't have a mapping for R3. So this is R4 and this is like himself. He resolved himself. So see, first packet went to R1 and then the second packet will go to 1.3, that is R3. So this is your phase 2. Now if you check the NHRP, you should have a mapping for R3. And now if you do the consecutive trace route, it will go directly to R3. So this is your DMVPN phase 2, right? Let's move on to phase 3. Okay, before that, we'll check this next stop. Yeah, R3 directly. Okay. Okay, to begin with your, the phase 3, what we need to change is we need to go to your interface tunnel 10 and this needs to be applied back. So the spoke to spoke mapping should always go through your R1, right? So here what we do is we go to your R1, right, and specify a command to your this tunnel IP NHRP. It says redirect. This is the command I specify on my R1, and on my spokes again I go to interface tunnel 10 tunnel 10 I say IP NHRP shortcut, right? On R3 R4 conf interface tunnel 10 IP NHRP shortcut, and on R5 also config interface tunnel 10 IP NHRP shortcut. So let me explain this to you. So the command IP NHRP redirect, what it does is the hub actually. What it does is it pushes down a dynamic mapping to the spokes for the spoke internal routes. Okay, I mean the routes that you saw, right, having 1.1, right? So that will be always there. It will not change the next hop. It will not change the next hop, but you will have a mapping, dynamic mapping, right? Like in the phase 2, the next hop was changed, right? This thing. It will always point to 1.1, but you will have a mapping here dynamically. It is pushed by your hub, and because of the shortcut command, it is accepted by your spokes, right? Okay. So if you check the routing table, it will always point to the hub. That's what the main thing is. Actually, the hub detects that the spokes are both connected on the same tunnel interface, right? Spokes are connected on the same tunnel interface, and sends an NHRP, sorry, and sends an NHRP redirect message to both of them. Okay, the NHRP redirect message contains the mapping for the destination public IP for the internet networks. I mean the internet networks. Okay, the loopbacks. Okay, you will see the loopbacks mapping there now. So if you go to your spokes here, if you say this show IP NHRP, if you do, let's do a ping here. So from R5, let's do a ping dot 3 source of loopbacks 0. This is successful. If I do this again, so you should have, see, now you have mapping for your loopbacks, right? So again, if you do for say 33, right? So now if you do see the NHRP, you will have a mapping for 33. So that is phase 3, right? You will have the mapping for your loopbacks, I mean for the internet networks. Okay? So this is your phase 3. One more interesting that I want to show you is what if the hub goes down? Let's do one thing. I'll go to hub and stop it. Now tell me, do you think the connectivity is there? If I go here, if I do this ping, will it work? See, neighborship will be down. Neighborship is going down. Will this work? No, right? So if you see, this thing isn't working. So this is from R5 to. So if you ping the next hub, I think that is going to work. Ping 192.168.1 dot. Say I'm on R5 and I'll ping 3. This will work. This will work. Okay, because I have the mapping. So show IP NHRP. If I do, I have the mapping to 431, right? 4351. That is my set. So if I ping 192.168.1.4, it's working. 3 will be working, right? 1 is downstream. So for this, what we'll do is we will go for the dual hub DMVPN. So I think this is enough for this video. It's already more than an hour. So I'll show the dual hub DMVPN in the next video. So thanks for watching my video, and kindly do subscribe to my channel, and don't forget to like and share my channel as much as possible. Even like and share my videos, right? So yeah, that's it for all. Thank you. Bye bye.